Hi everyone, I'm Ravi Handa. Welcome to another video on number system. We need to figure out how many factors of this are perfect squares which are greater than 1. So I can just look at it and say that this entire thing is divisible by 4, it is also divisible by 9, it is also divisible by 100, which are all perfect squares. But this is not going to be good enough. I will not be able to count all of them out. So I need a more methodical approach for solving this question. So how do I do that? Well, first of all, whatever number is given to me, let me write that down as a prime factor. So this is 2 to the power 4 into 3 to the power 5, and then I have a 10 to the power of 4, which is nothing else but 2 to the power of 4 and 5 to the power of 4, which will form 10 to the power of 4. So my number n that I am looking for, that is given to me, is not just 2 to the power of 4, but 2 to the power of 4 into 2 to the power of 4, or 2 to the power of 8 into 3 to the power of 5 into 5 to the power of 4. Now, we need to consider a factor of this, which is f, such that f is a perfect square, which means whatever prime numbers are there in f, first of all, they can only be 2 or 3 or 5, whatever are their powers. So let's say the power is a, b, and c here. We want f to be a perfect square. And when will f be a perfect square? When the powers given here, that is a, b, and c, these powers are even. So all we need to do is we need to figure out what values are possible for a, b, and c. So let's check what powers are possible for 2 here. That means what values are possible for a, which are even. So maximum it can be 8, which means a can be 0, 2, 4, 6 or 8. Very similarly, b, maximum power of 3 here is 5. So what all powers are possible in f, which is a factor of n? 0, 2 and 4 are the even powers which are possible. And very similarly for c, highest power for 5 is 4. That means the value of c, which makes f a factor of n, can only be 0, 2 or 4. See, what you need to understand is that what if f is a factor of n, whatever is a is less than or equal to 8, b is less than or equal to 5, and c is less than or equal to 4. So less than equal to 4 and we need them even, that is what gives me these values. What is the total number of values which are possible here? Total number of values possible for A is 5, for B is 3, and for C is also 3. So overall, number of values which are possible for F could be any combination of this. So the number of values which are possible for F are 45, which means perfect squares that are a factor of n are 45, but we need perfect squares which are greater than 1, so we should not consider 1, which means if you remove that one particular perfect square, which is 1, you are left with 44 perfect squares, and that will be my answer. Once again, to quickly summarize, we first did the prime factorization of n, then we looked at f, which was a factor of n, which gave me 2 to the power of a, 3 to the power of b, 5 to the power of c. Powers in the factor have to be less than or equal to the original powers. Since f was a perfect square, the powers had to be even. We figured out the choices for a, b, and c. We figured out the total number of values which are possible for f. We found out 45 factors of n are perfect square. We removed one. Which one? 1 is what we removed. So we got 44 possible numbers which are perfect squares and factors of the given number. Hope you will be able to solve questions like this in the exam from now on. Thank you.
Please remember to subscribe to our YouTube channel and press the bell icon to get notifications of future videos.